A team of researchers from MIT, Harvard University, and City University of Hong Kong have developed tiny agile drones who look, act, and maneuver like actual insects. This new generation of tiny drones are powered by a new class of soft actuator made of thin rubber cylinders coated in carbon nanotubes. When voltage is applied to the carbon nanotubes, they produce an electrostatic force that squeezes and elongates the rubber cylinder. Repeated elongation and contraction is what causes the drone's wings to beat very fast and with enough power density to actually support flight. Typically, drones require wide-open spaces because they're neither nimble enough to navigate confined ones nor robust enough to withstand collisions in a crowd. However, these insect-sized drones can flap its tiny wings nearly 500 times per second, giving it the ability to recover if hit or involved in a collision, and do some aggressive maneuvers like somersaults in the air. This insect-like resilience is packed into just 0.6 grams, the approximate weight of a large bumblebee. The researchers hope one day the robots could aid humans by pollinating crops or completing search and rescue missions and navigating complex machinery to ensure safety and functionality.